What if the farthest corners of the universe were within our reach? Imagine the immense possibilities if we could traverse the cosmos as easily as we commute to work. Warp drives, a concept popularized in science fiction, could potentially make this dream a reality. In the realm of science fiction, Star Trek's Enterprise D and Star Wars' Millennium Falcon exemplify the spectacular potential of warp drives. The Enterprise D can supposedly travel at speeds 9,000 times the speed of light, while the Millennium Falcon claims a mind-boggling 9 million times the speed of light. These numbers are awe-inspiring when compared to our current space exploration capabilities. For instance, the fastest man-made object, the Juno probe, moves at a snail's pace of 0.0002 times the speed of light. To put that into perspective, it would take Juno about 20,000 years to reach Proxima Centauri, the nearest alien planet. But what if we could tap into the power of warp drives? Could we overcome the limitations of Einstein's relativity and make the vast universe a little smaller? Could we compress the cosmos into manageable distances, bringing distant galaxies within our reach? This is where the fascinating world of warp drives comes into the picture. In theory, a warp drive could manipulate the fabric of space-time itself, allowing a spaceship to travel faster than the speed of light without breaking any physical laws. It's like folding a paper in half. By warping space, you can bring two distant points closer together, allowing for instantaneous travel between them. However, as tantalizing as it sounds, the concept of warp drives remains firmly in the realm of theoretical physics. We're still far from developing a real-world warp drive. Even so, the idea continues to captivate the imagination of scientists and dreamers alike. The science behind warp drives is complex and filled with challenges. Yet the possibilities it offers are too enticing to ignore. From Star Trek's warp drive to Alcubierre's geometric solutions, the potential for manipulating time and space has never been more exciting. But is warp drive just a fantasy? Or could we actually bring this concept to life? It's a question that continues to fuel our fascination and drive our exploration of the universe. As we delve deeper into the mysteries of warp drives, one thing is clear. The universe is full of possibilities, and we're just beginning to scratch the surface. Enter Miguel Alcubierre, a physicist with a groundbreaking idea. In 1994, Alcubierre proposed a novel concept that would manipulate Einstein's equations of general relativity to create a warp field around a spaceship. This was not a simple tweak, but a complete redefinition of the geometry of spacetime. Alcubierre envisioned a spaceship enclosed within a warp field, a bubble of spacetime that moves the spaceship while the ship itself remains stationary. This concept, often compared to a surfer riding a wave, involves compressing space in front of the spaceship and expanding it behind. In essence, the spaceship doesn't move through space, rather, space moves around it. This approach cleverly sidesteps Einstein's speed limit, which applies to objects moving through space but not to space itself. According to Alcubierre, a spaceship could potentially travel faster than light without violating any laws of physics. This is because the spaceship would remain stationary within the warp bubble, while the bubble itself would move through space. But how is this possible? The answer lies in the very fabric of the universe. There are observations of space expanding at speeds exceeding that of light, in the farthest reaches of the universe and within the mysterious confines of black holes. This expansion of space, which does not violate Einstein's laws, is what Alcubierre's warp drive concept exploits. Alcubierre's geometric solutions to the equations of general relativity are complex and fascinating. They propose a method of manipulating spacetime that could, in theory, allow us to travel to distant galaxies in a fraction of the time it would take with current technology. However, these solutions are still purely theoretical and require further research and experimentation to become reality. Despite the challenges, Alcubierre's warp drive concept has taken us a step closer to understanding the true potential of space-time manipulation. It has opened up new possibilities for interstellar travel and has given us a glimpse into a future where the stars may not be as out of reach as they seem. Observations of space expanding beyond the speed of light in distant corners of the universe and within black holes provide a solid foundation for Alcubierre's ideas. The journey towards realizing warp drive technology is long and complex, but the first steps have been taken. Achieving a warp drive, however, is not as easy as it may sound. The primary challenge lies in the very fabric of space itself, which is incredibly stiff. This stiffness is represented by a complex equation involving the speed of light raised to the fourth power, requiring an immense concentration of mass, or its energy equivalent, to manipulate. But it's not just any energy that will do. The energy required for a warp drive is anything but conventional. It necessitates the existence of negative mass and negative energy. In essence, we're looking for components that exhibit anti-gravity properties, something that currently remains undiscovered in our universe. When Alcubierre first introduced his geometric solutions for warp drives, his initial equations suggested an unfeasible requirement: all the mass in the universe. This would make warp drives a mere fantasy, an impossibility beyond our reach. However, hope was ignited when NASA physicist Harold White stepped onto the scene. White proposed innovative modifications to Alcubierre's equations, drastically reducing the requirement for negative energy. Now, instead of all the mass in the universe, we would need only about 700 kilograms. With this reduction, the concept of warp drives shifted from the realm of pure fantasy to a tantalizing possibility. But White didn't stop there. He also proposed a torus-shaped warp bubble and an oscillating negative energy field. These enhancements could further improve the efficiency of the warp field, making the warp drive concept even more plausible. Despite these breakthroughs, the path to warp drives is still fraught with challenges. Scientists at NASA's Advanced Propulsion Team, also known as EagleWorks, are diligently working on these problems. They're exploring methods to manipulate space-time, even going as far as to slightly warp the trajectory of a photon in tabletop tests. While warp drives remain theoretical, even achieving speeds of 10% of light speed would be a monumental leap forward. The concept of negative energy, inspired by the mysterious dark energy that propels the universe's accelerated expansion, may offer a solution. White's innovative modifications present a potential path forward, but many challenges still remain. Despite these challenges, scientists are not giving up on warp drives. They continue to push the boundaries of what we once thought impossible, and the future of warp drives looks promising, albeit peppered with intricate hurdles to overcome. At the forefront of this research is NASA's Advanced Propulsion Team, often referred to as EagleWorks. This dedicated team of scientists and engineers are dabbling in the realms of the seemingly impossible, conducting experiments that could lay the foundation for warp drive technology. Their work is groundbreaking, yet largely underappreciated due to the abstract nature of the science involved. In one of their most notable experiments, they've managed to warp the trajectory of a photon ever so slightly, a feat that, while minute, indicates the theoretical feasibility of a warp drive. The idea is to manipulate space-time itself, a concept that, if actualized, could revolutionize the way we traverse the cosmos. Another glimmer of hope lies in the potential of achieving 10% of the speed of light. This might sound insignificant compared to the fantastical speeds quoted in science fiction, but even at this speed, we could reach Proxima Centauri in just over 40 years. That's a significant leap from the current 20,000 years it would take our fastest spacecraft. The key to this future could lie in the concept of negative energy. This mysterious form of energy, inspired by the enigmatic dark energy that propels the universe's accelerated expansion, might just hold the key to warp drives. With its anti-gravity properties, negative energy could theoretically bend space-time, enabling faster-than-light travel without violating Einstein's laws. With 70% of our universe composed of dark energy, could its anti-gravity properties be the key to unlocking the potential of warp drives? The answer to that question remains shrouded in the mystery of the cosmos. But one thing's for sure: as we continue to explore the fabric of the universe, we inch ever closer to the future of warp drives. Let's recap what we've explored today. We began our journey with the concept of warp drives, a staple of science fiction that allows for faster-than-light travel. The idea, while seemingly far-fetched, is rooted in the potential manipulation of space-time, a possibility that has sparked the curiosity of scientists and space enthusiasts alike. We then delved into Alcubierre's geometric solutions, a groundbreaking theoretical framework that reshapes Einstein's equations of general relativity. This manipulation allows for the creation of a warp field around a spaceship, compressing space in front of the ship and expanding it behind, much like a surfer riding a wave. This concept cleverly circumvents Einstein's speed limit, as it applies only to objects within space, not to space itself. However, the path to warp drives is not without hurdles. The creation of a warp field necessitates a concentration of mass or energy, but not just any kind of energy. We're talking about negative mass and negative energy, essentially anti-gravity components, which are currently undiscovered. The initial calculations proposed by Alcubierre required a mass equivalent to the entire universe, a figure that was thankfully reduced to around 700 kilograms by NASA physicist Harold White's modifications. And finally, we looked at the ongoing research into warp drives. Scientists at NASA's Advanced Propulsion Team, or EagleWorks, are actively investigating the feasibility of warp drive technology. Their attempts to warp the trajectory of a photon in tabletop tests may seem modest, but they represent a significant step towards the realization of warp drives. The journey to warp drives is filled with challenges, but the potential rewards are too great to ignore. As we continue to push the boundaries of science, who knows what we might discover? From the far reaches of our galaxy to the depths of black holes, the quest for warp drive